My number one piece of advice for beginners who are hoping to learn how to code and land their first jobs as software engineers is to learn the complete fundamentals of JavaScript. In this episode, we're going to talk about why, and then we're actually going to learn the complete fundamentals of JavaScript. Of course, actually learning JavaScript will probably take you a few weeks, but the hope is that this audio guide to the complete fundamentals of JavaScript will set you up for success. Whether you've been working on JavaScript for a while or you've never even touched it, we're going to cover everything that you need to know and everything that you need to learn to become competent in the fundamentals of JavaScript. Welcome to the Develop Yourself podcast, where we teach you everything you need to land your first job as a software developer by developing yourself, developing your skills, your network, your habits, and more. I'm your host, Aaron Haslip, and today we're going to talk through why my number one piece of advice for new beginners is to learn JavaScript first. And then we're going to walk through basically the entirety of the language to understand some context around what JavaScript is and all of its parts. All right, so we're going to break this episode down into two main parts. The first part being why we recommend JavaScript, learning JavaScript as a first step for a brand new beginner hoping to learn to code and then get a job as a software engineer. Then we're going to move into actually talking through JavaScript itself. This is kind of a strange format for this since it's only audio, right? So you're not actually going to be able to play around with JavaScript and test out what I'm talking through. But we're going to talk about JavaScript, its environment, declaring variables, doing math, control flow, conditionals, different data types, creating functions, arrays, loops, objects, all those things. We're going to define those. And hopefully at the end of this, you have some context for JavaScript itself, which will reinforce what you've already learned or give you context for what's to come on your learning journey. All right, so why is my number one piece of advice for a first step for someone to learn JavaScript? So I'm going to break that down a little bit more. First of all, it's not necessarily to learn JavaScript. If you don't know of a language that you should learn, so if you're brand new to coding, you just don't even know where to start, then I'm going to recommend JavaScript. We're going to get to those reasons as to why here in a minute. But first, let me say that the important piece here is to learn a programming language. There's a huge difference, by the way, between a programming language and a markup language. If you go online to any of the famous Learn to Code sites, so codecademy.com, or you purchase a Udemy course, they'll often start you with learning HTML and CSS. And that's great because as you're learning HTML and CSS, you're getting an instant feedback loop. You in CSS say, hey, let's change this H1 to red, and it immediately changes the text of the website from just black to red. So you're thinking to yourself, okay, there's a lot to learn here, but I can do this. This is pretty easy. But oftentimes what happens then is someone moves in from the tutorial from HTML and CSS, which they could probably pick up in a weekend, into JavaScript, and then suddenly get slapped in the face. And you think to yourself, oh, I like programming, but I just like HTML and CSS. I don't like JavaScript. There's probably a better language out there for me to learn, like Python, Ruby, etc. But what's going on here is JavaScript is an actual programming language. HTML and CSS, they are not programming languages. These are markup languages. So the programming language has logic, right? You can control the flow of how something works. You have the if-else statements. You have functions that can manipulate actions. You've got data structures. Every programming language is like this. JavaScript isn't necessarily unique to that. So at this point, I should encourage you that if you learn any programming language, you're going to get over that hump of the experience that you're having to go through, which is learning JavaScript. So the reason why JavaScript is hard is not because JavaScript's hard, it's because learning to program is hard. So my experience has been, if I can start someone with learning a programming language in its entirety first, then they can know whether or not they're a good fit for learning to code. Because if you figure out that you like HTML and CSS, that doesn't necessarily mean you're going to be a great programmer, because there's actually no programming involved in HTML and CSS. Another thing I would say about this being the first step is it's probably going to be the most difficult part of your entire learn to code journey. And the reason for that is because there is no feedback loop, right? With HTML and CSS, there's an instant feedback loop. In the beginning, when you learn JavaScript, there's almost no feedback loop. You have to learn the entirety of the language, which we're going to go into here in a moment, but you're going to have to learn variables. You're going to have to do a deep dive into conditionals, data types, functions, arrays, loops, objects, and all the while, every time you're learning one of these, specific aspects of the language, you're not learning it in context necessarily of the rest of the language. You have to learn all these individual parts, which may take several days or weeks to learn. And it's not until you've learned all these individual parts can you put them all together and build a program. And at this point, it's going to be a very simple program that doesn't really do anything exciting. And once you're able to build a few of those programs with all of JavaScript, finally, you're able to actually start building applications that give you a sense of gratification. And that's where programming becomes addicting, because you're building stuff, and building stuff is really exciting. It's really fun. You start to explore and use your creativity. So all that to say, this is why it's my number one piece of advice. If you can get over this initial hump of learning the fundamentals of a programming language, then you can finally begin to make progress. And as a side note here, another reason why I recommend this kind of intense focus on learning one programming language first is what we call the learning cycle of death, right? Where as a beginner, you don't know the best thing to learn. And so you start down one path, maybe you're learning Python, and then your cousin tells you to start learning JavaScript. So you kind of start over and you start learning JavaScript. And then the internet article tells you to learn Ruby, and you start learning Ruby. Before you know it, you can define variables in 3 different languages, but you don't really know any one language on its own. You know about 10% of 3 different languages. That's just one example of the learning cycle of death. You might do this 1,000 different ways, but the point here is to take some prolonged focus in one direction until you've finally acquired a skill, and then you can build upon that skill. So hopefully at this point, you're convinced to stick it out and learn one programming language first before you do anything else, to do a deep dive into one specific programming language. Just suck it up that you're not going to understand in the beginning why you would need to learn about arrays, functions, etc. We're going to try and talk about that here in a moment. But before we move on to talking about what JavaScript is, I want to explain why we say if you don't already have a language picked out that you want to learn, then go with JavaScript. At Parsity, our online code school, we teach JavaScript not because we think it's the best language to learn. And this is something you're going to hear quite a bit from software engineers, is that you should be language agnostic, right? You should pick the language that makes the most sense for the context, right? So if, for example, Python is well known for machine learning, but you wouldn't necessarily use JavaScript for machine learning. So that being said, let me kind of go through a few reasons why we teach JavaScript in particular. The foremost probably being the fact that it's a good learning tool. You could pretty much do everything with JavaScript. You can build a front-end application, a back-end application. You can even use some databases like Mongo using the JavaScript syntax. So the main idea there is whenever you're trying to learn how to become a software engineer in 3 to 6 months, it makes sense not to try and learn more than one language simultaneously, right? At the same time. It's kind of like if you were going to learn a foreign language. Let's say you wanted to learn French and Spanish, you wouldn't want to learn them at the same time. It would confuse you too much. But learning French first might help you learn Spanish down the road, or vice versa, because you realize that there's an overlap of the techniques that you need to employ in order to learn a language. And the same thing is true with programming languages, right? There are some version of functions in all languages. There's some version of arrays and loops and objects. All these things that we're going to learn about in JavaScript exist in other languages as well in different ways. So really, after you've learned this first language, the next one should be relatively easy. So that's JavaScript as a learning tool. It's great to not have to switch context, switch languages as you're learning something, because JavaScript can do most everything you would need to do in modern software development. It's a great first tool to learn. Also, JavaScript is a great first language to learn because you can do almost anything with it. And to kind of explain this, I want to give you some context around what modern software development looks like and what role JavaScript plays. So that being said, when was the last time you went to Best Buy? I'm a 90s kid, so there's some context there for where I grew up. When's the last time you went into a Best Buy and you bought software? Right? You bought one of those little cardboard boxes, whether it be Microsoft Word, or I remember Adobe products would often be for sale at Best Buy along with a number of games. And you'd go buy the software for $50 or whatever it was. You could bring it home, you'd open the box, take out the installation manual, you would take out a CD-ROM and put it in the computer. And after, maybe a half day, however long it took you to get this thing up and going and installed, you'd have that new software on your computer and it would forever live on that computer. And then if you wanted to get the next version, if it needed to be upgraded, right? The next version of Word, the next Sims game, you'd have to go back to the store and buy the new update. Now, why don't we do that anymore? Well, the answer is the internet, right? Computers have become powerful enough and the internet has become fast enough that if we want a new version of software, we just go to the website. So a great example of this is Facebook, right? Facebook is a complex piece of software that literally connects billions of people every minute. And annoyingly, they often release new versions of the Facebook software. But how do you know when they release new versions? Do you go out to the store and do you buy it? Well, you don't even buy Facebook at all, do you? Facebook gets paid for by ad revenue. Instead, what happens is you just refresh your browser or you leave the website and come back and it looks different. Which, if you think about it, it's incredible. The developers at Facebook are able to update Facebook and push upgrades to it any second, and immediately all its users will experience the new software. So this is primarily what software development looks like these days. It looks like web development. These complicated pieces of software live as websites in the browser. So if that's the case, then we need to ask ourselves the question, what is the difference between a website and a web application? Well, simply put, I'd say that a website is static, right? It's got some data, kind of like a newspaper, right? Whenever you read the newspaper, it's static. Someone created it once, they published it, they pushed it off, and basically just text and photos, maybe some videos. You can look at different pages, but more or less, it doesn't do anything. It's not interactive. The data that it has is static. Someone hard coded it, they wrote it in there. It's not going to change. Now, a web application, on the other hand, usually has some sort of dynamic data. And in fact, these days, most websites that are usable, beyond a portfolio website or a really small website, most well-known websites are in fact web applications, right? You can buy products from Amazon, you can search the web from Google, you can check your email from Gmail, you can look at tweets on Twitter, posts on Instagram, etc. These are mostly going to be in the world, in the realm of web applications. And in fact, these companies employ thousands of engineers who develop these web applications. And within a web application, by the way, we're going to get to JavaScript here in a moment. Within a web application, we often think of it in terms of the front end and the back end. We think about the architecture of it, how it's built, just like a building, its foundation, its structure. We think about the front end and the back end. You probably hear these terms thrown out a lot. We could dive into this deeper probably, but for brevity's sake, we're going to say that the front end is what the user sees, right? So whenever you go to Google Chrome or whatever web browser you use and you go to a website, what you are actually seeing with your eyes is the front end. It's made up of HTML and CSS. HTML is the content, it's the skeleton, the structure, it's the actual text, right? That's what HTML is. The CSS is sort of the skin. It's what gives it the style, the color, the arrangement of things. It's what makes it pretty, essentially. And then the back end is the stuff that you don't see. It's the data, how the data is stored, served up, retrieved, etc. So for example, if you're on Facebook and you post a post to Facebook, right? If you post it on your wall and you say, "Man, I really like cheese," right? That text, "Man, I really like cheese," is getting sent off to some data warehouse that Facebook houses its data, whether that be through Amazon. I don't know how Facebook houses data, but there's literally a server somewhere, which is a special computer that holds data and can send and receive that data. There's literally a server somewhere in the middle of nowhere inside of a server farm, which is a massive building with tons of computers. And that piece of text is stored somewhere on a hard drive. And it's going to be retrieved later anytime you reload the page, etc. Right? So the data of your website, that is not stored on your computer. That's just stored somewhere else. And because of the internet connection, every time you load up that web page, it's going to go reach out for that data. And so the backend is concerned with how that data gets retrieved, how quickly it gets retrieved, where it gets stored, maybe even the authentication, your login, logout, etc. That's how that works. Okay, we haven't yet started talking about JavaScript. Where is JavaScript at? Well, JavaScript lives in the browser. Remember, HTML and CSS also live in the browser, but JavaScript lives in the browser too. HTML and CSS are markup. It makes a pretty picture and gives you content. JavaScript controls how that content, when it gets rendered, the actual retrieval of the data. It's basically the physical dispatcher that enables it to happen. Then on the back end, there could be a variety of languages that the back end is programmed in. It might be Python, it might be Ruby, it could even be JavaScript. And this is kind of a newer thing. Since 2009, we can actually use JavaScript on the back end as well as the front end. But you can be sure that no matter what, there is JavaScript on any given application in the browser. Because of a long history, basically JavaScript is the default language of every web browser in the world. Which means, and this is rounding out my other point of why you should learn JavaScript, you could conceive and make an argument for if there is a company, and if that company is on the internet, then someone, somewhere, somehow is being paid, maybe not full time, but is being paid to write JavaScript, right? Because if the company is a tech company, it's on the internet. Even if the company is not a tech company, it's on the internet. If it's on the internet, it means it's accessible by a web browser. If it's accessible by a web browser, it means someone's writing JavaScript. So that being said, if you know JavaScript, no doubt you can get a job. All right, that being said, we are going to move into actually walking through JavaScript itself. And there are going to be 7 parts to this. I'm going to go over those real quick, and then we're going to start marching through them. 1 is declaring variables. 2 is control flow with conditionals. 3 is the 7 JavaScript data types. 4 is functions. 5 arrays. 6 loops. And 7 objects. That will cover the entirety of the fundamentals of JavaScript. And what I love about explaining that right off the bat to new learners is you can know where you're going. And if you can know where you're going, then you can prevent yourself from getting overwhelmed. So 7 parts, that's all of JavaScript. There's a lot more to JavaScript, obviously, in terms of complexity and depth. But if you know those 7 things, then you can write programs with JavaScript. But before we get to those 7 parts, let's real quick talk about the environment. Where would you actually write this JavaScript? Well, as we've said, mostly it gets executed inside of the web browser. So if you're in Google Chrome or Firefox or whatever web browser you're using, behind the scenes, under the hood, JavaScript is at work doing something depending on what website or application you're actually using. So you could open up what's called the developer console, and there's actually a way to do this. If you're in Chrome, you can go up to the top and go to View. Then if you click Developer, and then arrow on over to where it says JavaScript console, and that will pop open a little bit of console where you can type some things in. And when you're typing those things in, it's JavaScript. So you're essentially typing JavaScript in to do something. Now, most of the time, this is not where people would write their JavaScript. You would write JavaScript in a file somehow. Now, bear with me real quick. You might not understand this part right now, but it's okay. To write JavaScript in the browser via a file, you would need to create a folder. And inside that folder, create basically an HTML file. And then beside it, create a JavaScript file. All that is a plain file on your computer. The JavaScript file has the extension .js, and the HTML file has the extension .html. Inside your HTML file, you would write some HTML code that linked in the JavaScript file. So it'd be called a script tag is what you use. And it basically says, hey, when this HTML file loads, we also want to load this JavaScript file. And then you would open up that HTML file inside of your browser. So you could literally go up to Chrome. You could go into Google Chrome, go to File, click Open File, and you could open that HTML file, and Chrome would know what to do with it. It would know this is HTML. It would know how to display any HTML if it's displayed. And if there's that script tag that pulls in that JavaScript file that you wrote, then it would pull that JavaScript file in as well, and it would basically evaluate all that code. It would run that code inside of the JavaScript console. Now, in the beginning, that's probably a little bit too complex. So there's a website where you can actually write JavaScript. If you go to repl.it, that's repl.it, you can go there. You can immediately click this button that says Start Coding, create an account, and then pick a language. You can code in any language here, so you can kind of write JavaScript. So if you want to follow along and kind of play along with JavaScript, that's a great place to do it. But assuming that you're just listening to this, we're going to move on to this first part, which is declaring variables in JavaScript. So you've probably heard of the word variable before. And we use variables in math. Oftentimes we have things called variables, or even the word variable means changing, right? It can be something different depending on several factors. In JavaScript, variables are essentially keywords that we create that point to pieces of data inside of our program. In programming, a good variable is descriptive of what it's pointing to. So for example, if I wanted to create a variable with my full name, I could say var, and that's var, that's the text I use to declare a variable. I have a space, then I just say my name. And my name would be probably camel cased. In JavaScript, it's convention that all variables would be lowercase. If you have two words together, the variable needs to be one continuous line of characters. So to distinguish the two words in the variable my name, we would camel case it. So what camel casing is whenever you have different casings put together. So my name would be lowercase m, lowercase y, uppercase n, lowercase a, lowercase n, lowercase e. So my name, camel cased. And then I would do an equal sign, just a single equal sign, which means assignment. And then I would probably have a string of text, will be quotes. And I could say my full name, Aaron Michael Hayslip, which is great because from now on in the program, instead of having to write this word or this phrase, Aaron Michael Hayslip, over and over again, I can just reference my name because my name points to this string, Aaron Michael Hayslip. So again, a variable is just a way to reference something, some piece of data, and we'll talk about data types here in a moment, in JavaScript. And most languages, I think probably every language has variables. And as you'll see, as you grow in programming and as you learn JavaScript, for example, you'll understand why a language would want to use variables. It just makes it much easier to call upon data that we want to be consistent with. Sort of an example of this is take the James Bond film series. You have Q, right? Q is usually he's like the weapons guy. He's always got some kind of new gadget for James Bond. Q is short for quartermaster. So instead of James Bond having to say, hey, quartermaster, how's it going, quartermaster? Or, oh, you should get your weapons from a quartermaster, he can just say Q, right? It's short. We all know what it means. We know what it points to, kind of like a variable in JavaScript. All right, the next piece of JavaScript to learn is control flow with conditionals. What is a conditional? Well, you're probably actually familiar with conditionals. This is probably what you think of when you think of programming. A conditional is an if-else statement. And in JavaScript, we have if statements, we have else, and then we have else-if. And I'm going to kind of go through what this might look like. Basically, an if statement asks if some kind of statement is true or not. So let's say that you had an application that acted as a gatekeeper for a bar. And in order for you to enter this bar, you have to be at least 21 years old. So the first thing we might do is we might capture the age of the person who's currently trying to enter into the bar in a variable. So we would declare a variable called age. And then somehow in our program, it would assign a number to that age variable. So let's say that in this case, the age is 17. We then might have a conditional, right? An if statement that says if age is greater than or equal to 21, right? And we can do this with JavaScript. They're called comparison operators, where we have greater than, less than, greater than, or equal to, less than or equal to, does not equal. All of these tools are available to us in JavaScript to basically get equality between two different variables, or a variable and a number, or a variable and a string. And we're going to go over data types, like I said here, in a moment. But basically, our if statement could say that if age is greater than or equal to 21, and then we can set up a couple conditions. So if that's true, then we can run some code. Else, so the else condition would fire. If that wasn't true, we would run some different code. So that's why we call this control flow. We basically say, all right, based off of this condition, the truthiness or falsiness of this condition, we're going to go one way or the other. And so in the case that this statement, age is greater than or equal to 21, we're going to go down one path. If that is false, we're going to go down a different path. Obviously, the true path would give us some kind of message like, hey, welcome to the bar. And the false path, the else, would say, hey, sorry, you got to get out of here. You're not 21 quite yet. So that's essentially what conditionals are. And every programming language has them. In JavaScript, we've got if, we've got else. And then we've got else if as well. So normally whenever you would look at these conditionals, you might have an if case and then an else if, and you might have many else ifs, but finally you'd have an else case. You might not always have to have an an else if. You might not have to have an else, but again, these are things you can learn about as you dive deeper into JavaScript. Just know that there is a way to control the flow of your program, basically give it some intelligence with these statements that check for the truthiness of something. All right, number 3 here, we're gonna look at the 7 data types in JavaScript. And this is actually probably the beefiest sort of section here of things that we're gonna be talking about. So when we say a data type, right, every language has a number of data types. These data types are represented differently depending on the language. In JavaScript, we've got 7 data types. And when we say data type, we basically mean how data gets represented in the program. So ultimately, what programming is we're trying to do something in the real world, but digitally, right? In some way or another. We're trying to take real world data that humans, that we use and think about, and to condense it into a language that the computer can understand. So there's a number of different ways that we can actually describe real world data in terms of data in JavaScript. So in JavaScript, we've got 2 categories of data types. 6 of them are primitive, and 1 of them is complex. I'm going to explain what that means here in a moment. Our 6 primitive data types are, 1 is a Boolean. So a Boolean is true or false, right? Black or white. It's one or the other. And we would use a Boolean, for example, in the context of a conditional. We could say if true, then it's going to be truthy. If false, then it's going to be falsy. So basically what a conditional is asking is, what is the truthiness or falsiness of a given statement? It's basically wanting to ultimately condense down something into being a Boolean, true or false. Next, we have null. Null in JavaScript means nothing. It's not super useful, to be honest, but it is what it is. Null is nothing. So I could say var name equals null, which means I've declared a variable and it's just nothing yet. It's not actually a name. It's nothing. So in the future, again, you'll see opportunities to use this. Right now, it's kind of hard to imagine using null. Number 3 here, the third primitive value that we've got is called undefined, which is also strange because doesn't it seem a lot like null? And it does. Basically, undefined happens whenever we've created a variable, we've declared the variable, but we haven't actually pointed it to anything yet. So I could say var my name, and that's all I do. I don't actually point it to anything yet. So that means I've basically created a variable that I haven't yet defined. And this is sometimes useful because there might be parts in your program where variables sometimes get defined and they don't. So you might sometimes ask the question, hey, is this thing defined? And it might not be defined yet. So you might then control the flow of your program somewhere else because that thing hasn't been defined yet. Again, you'll have to experience undefined to really understand what it is. Next, we've got as our 4th primitive numbers. And hopefully this makes sense. Finally, a piece of data that makes sense, right? A number is a number. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's lots of weird things we could say about numbers. Like in JavaScript, we've got plus and minus affinity, NaN, not a number. But don't worry about any of that right now. Just know that in JavaScript, we have the ability to create numbers. So I could, the example that I gave earlier, var age equals 17. We would use the number 17. And with JavaScript, we can do math here. I could say age plus 3, and I would get 20, right? Because 17 plus 3 is 20. So we can actually do math with these numbers in JavaScript. All right, so that is, let's see, 1, 2, 3, 4. Primitive number 5 is the string. And this should also be a very familiar piece of data, and it's just text. So in JavaScript, to represent text, we put quotes around it. So if I wanted to declare my name as a variable, I'd say var my name, camel cased, equals, and I would use quotes, and inside quotes, I would write my name, Aaron Michael Hayslip. And strings, we can edit the strings, we can add characters, remove characters, figure out how many characters are in the string, etc. But as you can probably imagine, there are lots of use cases for using strings in JavaScript. And then finally, we have a primitive value called a symbol. And I'm honestly not going to go into it right now. I don't use symbols very much, to be honest, and they're pretty hard to explain. So just know that is another primitive value. And then finally, we go into the last and seventh value in JavaScript, and it's called an object. Now we said that the first 6 data types were primitives, and this last one is complex. Now, to be honest with you, I'm not really going to take the time to explain what a primitive is and what a complex is, but just be aware there are some differences in these data types and really how they work. And the main idea around these differences is how variables are referencing these different data types. But that being said, the object is one of 2 main data structures that we have in JavaScript. And this is where things get a little bit complicated because I just said that objects were one of 2 main data structures in JavaScript, yet it's the 7th of all the data types that we're talking about, and I haven't named another data structure. That's because there's 2 other things that we can think of as data types in JavaScript that are technically objects. So arrays and functions are technically objects. So again, the main data types in JavaScript, we've got the 6 primitives: booleans, null, undefined, number, string, and symbols. We have the 1 complex type, which is an object. And then we've got basically a bunch of built-in objects. And 2 of these built-in objects, probably the 2 most popular built-in objects in JavaScript, are the array and the function. And we're going to get to arrays and functions here in a minute, but let's talk about what objects are real quick. At its most basic level, an object in JavaScript is a data structure meant to group together key value pairs. And believe me, this sounds a lot more complicated than it is, so bear with me. A data structure is a way that we can take some of this data that we've already mentioned, so strings, numbers, booleans, and then create relationships between these different data types. So let me give you an example. Before, we had a variable, my name, that pointed to the string Aaron Michael Hayslip. So my full name represented as a string is Aaron Michael Hayslip. Well, what about my age? My age is 32. It can be represented as a number. So we have this string, Aaron Michael Hayslip, and then we have this number, 32. And on their own, they're just disparate pieces of data that exist in our program. But if we wanted to put them together, we would need a data structure. A data structure, basically a way to structure our data. So one of those data structures, remember there's 2 of them. There's the object and then the array. We'll go over the array in a minute. The object is a way to group data as key value pairs. So in the example I gave where I had the string Aaron Michael Hayslip, and then I had the number, which was my age, 32, the way we could do this in JavaScript is I could create a new object called me, or I could call it Aaron, right? I create a variable called Aaron, and I could point it to, syntactically the way it looks, and it's kind of hard to explain again over audio here, is these 2 squiggly braces. And then inside of it, there would be these key value pairs. So a key value pair being, we have a key, then a value. So in this case, the key, one of the keys, right? We'd have 2 keys. One of the keys would be name, another key would be age. Then the values of those 2 keys, the value of name would be the string Aaron Michael Hayslip, and the value of age would be the number 32. So an object in JavaScript is a data structure that puts together key value pairs, and it could basically have an unlimited number of key value pairs in this object. So that's what an object is. It's one of, like I've said, I think 10 times now, it's one of our 2 data structures. Now, the other built-in data structure in JavaScript is the array. Now, it's kind of complicated. We didn't mention it as one of our 7 JavaScript data types because technically it's a really fancy object, but that's probably going to confuse you more than anything else at the moment. So let's not think about that. Basically, an array is a list. Syntactically, the way it looks in JavaScript is you have these square brackets that show you the 2 ends of an array. And just like any other list, the thing that matters in the array is the order of items. There's no key value pairs. There are just single comma separated items inside of this array, which is a list. Now you can put anything you want in an array. You can mix in strings and numbers and functions and booleans inside of an array. But an example of an array might be my family, right? I might create a variable called my family, and I'd point it to an array using these square brackets. And inside the array, I might have 5 strings. So basically a list of members of my family. And in my family, I'm married and I've got 3 kids. And so it might look like this. We might first have the string Sarah, then the string Aaron, then the string Isaiah, then the string Jeremiah, then the string Mayan, right? Those are me and my wife and my 5 kids, 5 strings, comma separated in this list. So the relationship between these 5, which would otherwise be random strings, there's this relationship that gathers them together in this list called an array. Now, with an array, the items in the array have a certain order and they are indexed. So what indexes are essentially positions in the array. Just like if you were to go to one of those restaurants where you order at the counter, there's obviously a line, and then depending on the position that you're in the line will depend on when you get to order next. So in an array, we have indexes starting at 0 and ascending by number. So we have 0, 1, 2, 3, 4. In the example of my array where I have a family of 5, we've got 0 through 4 are the positions in the array. Now in the situation of my family, I put it in order of age, oldest to youngest. So my wife's actually older than I am. So she comes first, then me, then Isaiah, then Jeremiah, and then Mayan. It's in that order. So Sarah, my wife, is in the 0 index. Since I'm the second one, I'm in the 1 index, then the 2, then the 3, and then the 4. So that is essentially an array. And just like objects, arrays are extremely common whenever you're programming in JavaScript. So anytime you want a list of data, an array is going to be your best bet. And by the way, you can model almost any data for any application using just this combination of arrays and objects. So let's talk about Facebook real quick. When you log on to Facebook, the first thing you see is your feed. Now, your feed is a list of posts, right? So if we're going to simplify things, down as much as we can, we might say that a post contains some text and an author, right? That sounds an awful lot like an object to me. So the object here is this key value pair. It is a post. That's what we call the object. And it's got a key of user and a key of text. And the value is whoever the user is that posted the post. And the value of the text is a string of information, whatever text that actual user posted. So your feed will be made up of a bunch of these objects, right? As you scroll down, you see new posts that, again, behind the scenes, they come into your app via these JavaScript objects. Now, the feed itself might be an array. Again, because with an array, it's basically a list and the order matters. So the first thing in your feed would be at the 0 index of the array. The next thing would be at the 1. And then as you scroll down, you keep adding things to that array and you see more posts. So that is a simplified example of data structures in JavaScript. And to be honest with you, I would imagine that the real code behind Facebook is really not much different than that. You probably have an array that represents your feed, and each post in your feed would be an object. Okay, so there are really only 2 more things left to cover as far as the fundamentals, the basics of JavaScript is concerned. One is loops, the other is functions. But before we move on, at the risk of repeating myself, let's go ahead and review what we've covered so far. In the beginning, we talked about variables. Basically, variables are a way to create these keywords that reference pieces of data inside of our code. So instead of saying, every time we want to use a string, Aaron Michael Hayslip, we could just say my name, right? And that would point to this string. And we can create variables that would point to any different data types that we want in JavaScript. And we covered that there are 7 main different data types. 6 of them are primitives. We didn't define exactly what we meant by primitive, but these are strings, booleans, numbers, that kind of thing inside JavaScript. Then we said there is a complex data type in JavaScript called the object, and the object is essentially a key value pair. It's a way to pair together a key with a value, and these values are all different representations of our data type. So you might have a person who has a key of name and a value of Aaron, and the value would be a string, right? The name Aaron would be a string. We might have a key of age and the value of 32, and the value would be a number. We also talked about how technically there are a lot of built-in objects in JavaScript. And 2 of these, one actually being the object, are what we would call data structures. And data structures are essentially ways to create relationship between different data types in JavaScript or different pieces of data in general. So our two data structures in JavaScript are the object, which we just talked about, the key value pair, and then the array, which is essentially a list. All right, so let's dive into our last two pieces, loops and functions. They're not necessarily related, and we're going to talk about loops first because loops have something to do with arrays. So as we talked about with our array, every item in the array is indexed starting with 0. So it's basically an ascending list going from 0, 1, 2, 3, 4, 5. So I gave the example of my family. If we had an array that had 5 items in it, each item was a string and had the first name of a member of my immediate family. And so it was Sarah, Aaron, Isaiah, Jeremiah, Mayan. These are my 5 kids. Then we'd say Sarah, being the first item in the array, is in the 0 index, Aaron being the 1, Isaiah the 2, Jeremiah the 3, Mayan the 4. Now, if we wanted to, and this happens often in our programs, we could loop through this array. Now, what we mean by loop through this array is we could walk through the array and do something with every item in the array. So a real world example of this might be, let's say my family's at a restaurant and we all ordered water. The wait staff, the waiter or waitress, would have to come to our table and go through this list of individuals, my family, and hand each person a water. And let's actually take this a step further, and let's say that we're trying to program a robot. And this robot is a robot butler, and our robot butler is supposed to have the ability to hand each person in my family a cup of water. So at this point, I'm trying to translate something that is a very human activity, getting every person in our family a glass of water, into something that a robot can understand. And this is really the essence of programming. You're taking something that's real world and you're translating it into smaller, more easily digestible, bite-sized, very specific instructions. And as a side note, this is often what's probably the most difficult piece for folks learning to code in the beginning is we expect the computer is smarter than it actually is, or we expect that the programming language is smarter than it actually is. So we like to imagine that perhaps a computer can infer what it is that we're trying to tell it to do, when in fact the computer can't infer anything. It's like a robot. It will in fact walk off the bridge into the burning lake of lava if we give it the wrong instructions. It doesn't know what danger is. It's not smart enough to prevent itself from doing something wrong. So going back to this example of us programming our robot butler to give every person in my family a drink of water, the first thing I'm going to have to do is have it iterate through every person in my family. Iterating is basically a term for going to each person in my family and doing something. So this is what a loop is. With a loop, we can say continually do something until a certain condition has been met. And in this case, what we could say is until you've gone through the entire array, continue performing some action on every item in the array. So what this looks like is for Sarah, give her some water. For Aaron, give him some water. For Isaiah, give him some water. For Jeremiah, give him some water. For Mayan, give her some water. And if we've reached the end of the array, then we can stop giving out water. But if we have not reached the end of the array, then we should not stop giving out water. So this is the basic idea of a loop. And in JavaScript, there's a lot of built-in, what we call methods, basically built-in functions, which we're going to get to here in a minute, that allow us to do this more easily. We can loop through an array from front to back, from back to front. We can create a new array based off of the old array. So for example, let's say that we had this array called family, Sarah, Aaron, Isaiah, Jeremiah, Mayan, and we wanted to basically add the last name to all of these individuals. So now we want a new array that looks like the old one, but this new array not only has our first names, but also has our last names. So we would use a function that's built in to JavaScript called map that creates a new array based off of the old array. You don't have to remember that right now, but just know that this is one thing that we can do in JavaScript is loop through these data structures and create an action on every item in the data structure. Now, pretty much any time that arrays are present in programming, a loop of some kind is probably also going to be present. So going back to our example of Facebook, let's say that our Facebook app made a request to the Facebook servers. It pulled in all the posts for your feed. As we recalled, the posts in your feed is an array. It's one array full of all of the posts of your feed. Each post in the feed is an object. So probably what's going to happen with that Facebook app is there's going to be a loop that goes through every post in the array, and converts that individual JavaScript object into some HTML so the user can see it as a post. All right, and last but not least, let's talk about functions. To explain functions, let's go back to our analogy of creating a robot butler. Let's say that we want our robot butler to be able to make us a peanut butter and jelly sandwich. Now, the instructions for a peanut butter and jelly sandwich, for a robot at least, are quite complex, right? We might first say, okay, you have to go to the pantry, which is over here in the kitchen. You got to pull out bread, you got to pull out peanut butter, and then you have to go to the refrigerator, pull out jelly, then you have to go to the drawer and get a knife, then you have to get a plate, put the bread on the plate. First start by putting, and by the way, this can be a huge point of contention in the world, right? What do you do first? You do the jelly first, you do the peanut butter first. I do the peanut butter first on one side, then I wipe off my knife with a paper towel so I don't get peanut butter inside the jelly. And then I get the jelly out, I put it on the other side, I put them together, and I cut it in half, and then I have a peanut butter and jelly sandwich. Now, if you were converting these instructions to some kind of code, let's just kind of use our imagination here that there was code that you could write to make the robot butler do all of this, there'd be quite a few steps here. This is a lot of code. This isn't simple. But let's say you want your robot butler to be able to make a sandwich for a peanut butter and jelly sandwich for every person in your family. You wouldn't want to have to rewrite that code or re-explain to your robot butler every time you want them to make a peanut butter and jelly sandwich exactly how to do this. This is where functions come into play. Functions are essentially a way to wrap some code in an executable and execute that code again at some later point. And you can execute that function over and over again as many times as you want. And this is one of the most powerful parts of programming, the ability to write some code and then reuse it over and over again throughout your code, depending on what exactly you want to do. Now, one of the really cool parts of functions is that they can take what we call parameters. Now, don't zone out here because I use some word called parameter, which doesn't really make much sense in the way that we normally use language. Basically, what it means to allow a function to take a parameter is to allow a function to be able to be reused with different data every time it actually gets used. So going back to the example of our robot butler who can make a peanut butter and jelly sandwich, the robot butler might take a parameter called ingredients. And so maybe this function that we're creating for the robot to make a sandwich is just called make sandwich, right? It's the name of the function. But now that we've taught the robot how to make a peanut butter and jelly sandwich, perhaps we can give the robot any number of ingredients and they can make any kind of sandwich, right? So inside the function, right, the actual code that we're using to give the robot directions on how to make the sandwich, we have taken the ingredients, and instead of this function only being able to be used to make a peanut butter and jelly sandwich, we've made those ingredients, instead of peanut butter and jelly, parameters. So that depending on what data that we pass into the function, those items, peanut butter and jelly, could be mustard and cheese. It could be turkey and provolone. Now I get it, this example breaks down a little bit because you can't spread a slice of turkey onto a piece of bread like you could peanut butter, but just bear with me for the sake of the example here. So that's what a parameter is. It's a placeholder inside the body of a function, and that placeholder is not going to actually be defined until the function actually gets run. So in other words, I can teach my robot butler how to make a sandwich, but instead of telling the robot butler when I'm teaching them how to make a sandwich what ingredients to use, I'm just going to say, let's not talk about the ingredients yet. You'll know what the ingredients are whenever I actually ask you to make the sandwich. Then when it comes time to use this make sandwich function, I can actually pass in the different ingredients. And I can do this for maybe every member of my family. Let's say that I want a peanut butter and jelly, but my wife wants a turkey and cheese. My son wants hummus and ham, perhaps. And so when I call this function, whenever I actually invoke it, that's what we say whenever we want the function to actually run. We say we invoke it. I can pass this function different arguments. So those are a couple of keywords here, arguments and parameters. Arguments are the actual values that we give to the function when we are ready for the function to be invoked. So in this case, this is for the make sandwich function. Whenever we're ready for the robot, it's lunchtime, we're ready for them to make the sandwich, we're going to say that perhaps turkey and cheese are our arguments. Now, for the rest of the time, before this function gets invoked, we've got these parameters. These parameters are placeholders because we can't predict the future of our use of the robot, however many times we're going to use the make sandwich function, which days we're going to use it, what ingredients we'll pass into it. So we have these placeholders inside the function called parameters that are there and ready to be fulfilled by the arguments whenever the function gets invoked. So that's one way to think about functions. The other thing I want to add here about functions is that they are sort of the basic building blocks of any program, right? The idea of a function is that you give it some data, it does something with that data, and then it returns something else to you in a better form. In the example of our robot butler, we gave it some data. We said turkey and cheese, and what the function returned to us was a turkey and cheese sandwich. Now, after we've written the function, we don't really care about the code inside of the function as long as it works. From then on, we just care about passing it the raw ingredients and getting a function out of it. It's sort of like this magic black box that converts raw data into something more useful. And if you think about it, most programs that we use these days are just that, right? We go to Twitter, you type in some raw text from your computer, and suddenly what it outputs to you is a message that gets broadcast to the entire world, or however many followers you have. All you entered into that little black box of magic was some text or an image or something into Twitter. But what Twitter did for you is, through some magic of the black box of Twitter, it converted that thing into what we know as a tweet, a message that gets broadcasted to the world. And that's essentially what functions are. They are these black boxes of logic that we can create and reuse all over the place in our functions to do sometimes small, sometimes big, useful tasks that can take in different data and therefore make them even more helpful and reusable. All right, finally, let's put all of these things together to solve, a small but real problem that you might come across in JavaScript. Let's say that we are teachers. We're kindergarten teachers and we run a kindergarten class, and the students have been doing really awesome lately. And we've decided, hey, you have all won an ice cream party. Congratulations. But we can only have one flavor for the whole class. So we're going to take a vote so you can all choose your favorite ice cream flavor. And whichever flavor has the most votes is the flavor that we're going to eat on our ice cream party day. So we give the students three options. They can have chocolate, vanilla, or strawberry. They all vote, and now it's our job to create a program in JavaScript that can find out which ice cream flavor has the most votes. So to do this, we're going to put all the votes in an array, and we're just going to have strings, right? It's either a string of chocolate, a string of vanilla, or a string of strawberry. So let's imagine we have an array with 25 strings inside. Each one of these strings is either strawberry, chocolate, or vanilla. And our job using JavaScript is to figure out which one of these is represented the most, which string comes up in this array the most number of times. So it's at this point that we're using our problem-solving skills to think through how we might do this. And what we want to do ultimately is to display a relationship between a flavor, so that flavor is either chocolate, strawberry, or vanilla, and the number of times it gets represented in this array. So how do we create, or how do we display a relationship in JavaScript? Well, it's going to be with our data structures, right? So we have two main data structures. We have the object and we have the array. So in your mind, which one of these data structures is best for representing an individual flavor with the number of times it's represented? Well, if you're guessing object, because objects represent key value pairs and the flavor could be the key and the number of times it's represented could be the value, then you've guessed correctly. We basically want to convert this array of 25 strings into an object whose keys are the flavors and whose values are the number of times those flavors are represented. So to do that, the first thing we're going to do is declare a new object called flavor count. And it's going to be a blank object with nothing inside of it. Now we're going to use a loop to loop through the front of our array all the way to the back of it, to iterate over every string, every flavor in the array, and to begin counting how many times each flavor shows up. So let's imagine that the very first flavor that's represented in the array is chocolate. So remember, at this point, we're trying to tally the number of times chocolate is represented in the array, and we're using that object flavor count to keep track of this data. So the first thing I would do is to check flavor count and to see, hey, does chocolate already exist as a key inside of this object. If chocolate does already exist, then I'm going to increment its value by 1. If chocolate does not exist, I'm going to say that chocolate has showed up 1 time in this array. So at this point in the program, the object flavor count would have a key of chocolate and a value of 1. And then our loop would move on to the next item in the array, the item that's in the 1 index. And if it's chocolate again, our code that we've already written in this loop would increment that key, right, that value inside of the flavor count array of chocolate by 1. So now it has the key of chocolate and the value of 2. Now we're going to move on to the next item in the array, which is an index number 2. And let's say that we get to vanilla. Now, because of the way we've written our code first checks to see if flavor count has a key of vanilla. If it does not, it's going to set the value of that new key to 1. So now our object should look like an object that has 2 keys, chocolate and vanilla. The value of chocolate is 2 and the value of vanilla is 1. Now, if we keep on running this code to the end, ultimately what we'll have is our flavor count object is going to have 3 keys, chocolate, vanilla, and strawberry. And perhaps the chocolate key would have a value of 12, the vanilla key would have a value of 10, and the strawberry key would have a value of 3. So we've got a data structure now that represents the relationship between the flavors and the number of times they're represented inside of the array. Now, depending on the requirements of your program, you might need to take this a step further and perhaps, invoke, create a function that can convert this object into just a flavor that gives you the winning flavor. But hopefully that gives you a little bit of an idea of how you'd put some of these things together to solve a problem in JavaScript. All right, so that is a first taste of JavaScript. If you could actually learn each of the concepts we talked about in this episode, and nothing more, just each of the concepts we talked about in this episode, and then you could use JavaScript to solve a problem like the one we just talked about with the ice cream flavors, then you're probably going to be in really good shape to move to the next step of learning to code. If you'd like to review anything from this episode, we're gonna have timestamps in the show notes so that you can easily reference individual concepts in JavaScript. And again, I don't expect that at the end of this episode, you know JavaScript, but hopefully this gives you a better context for learning JavaScript. And hopefully you're convinced of your need to learn it and why you should learn it and why it is my number 1 piece of advice for beginners learning to code. Now, if you don't want to go about this alone, we do offer a prep course. If you go to parsity.io/prep, you will see that this is essentially exactly what we're going to be walking through in our prep course. It's broken up into 5 sections: declaring variables, conditionals, and math, then functions and scope, then arrays and loops, then iterators, and then objects and problem solving. For those of you that pay your deposit to hold your spot in Parsity, our online code school, this prep course to learn the fundamentals of JavaScript will be free for you, and it should be all that you need in order to pass our admissions code challenge. Again, that is parsity.io/prep, parsity.io/prep. Thanks for joining us. We'll see you again next week for another episode of Develop Yourself.